So let me get started here. I have this group of 5 questions that I'd like to go through. So this is the first in that group, and let me just get started. These should be relatively easy questions, but I thought it would be still good for me to demonstrate, just so that people sometimes I think it's easy, but then it ends up turning out not that easy. So, or I might think it's easy and it might be easy, but maybe some people need more practice, so it's not so easy for some people. So anyways, this question, it says a commuter backs our car out of our garage with an acceleration. So you are given some constant acceleration, and it's asking how long does it take. Okay, so when you're dealing with a constant acceleration problem, this is one of the few situations where it's nice to have certain formulas memorized. In high school physics, you might have seen this as kinematics equations. So let me write those down because I have a sense I'll be referring to them for this 5 group of questions. So let me just write them all down. There's one that describes a position as a function of time for constant acceleration. Initial position plus something that's attributable to initial velocity plus something that's attributable to the acceleration, 1/2 acceleration time squared. And there's an expression for the velocity as a function of time, initial velocity plus something that's attributable to the acceleration. And then there's a couple other formulas. I guess one that could come up is what I call V squared formula. I have it memorized in this form. V final squared is equal to V initial squared plus 2 times acceleration times delta x. And here the directions are important. You should make sure to reflect the directions when you choose the signs. So these are all for constant acceleration. Kinematics formulas. Okay, so here I'm looking at this question. I'm given the acceleration and I'm asked for time, and I'm given some kind of final speed. And the reason having these formulas is nice is you can kind of look at it or look at it in your mind, have it memorized, and kind of try to think through which of these formulas involve the quantities that you know, like the acceleration and the final speed, and ask for one quantity that you don't know. Like if you're looking at the position, that's not quite as helpful right now. But as you are looking at the velocity formula, you can see I think I have enough intuition about this question to say my initial velocity is equal to 0 because she's backing her car out, she's starting from rest. And so I'm given the acceleration, I'm given the final velocity, so V at t final is equal to 5.00 meters per second, and I can solve this for acceleration. And doing that algebra in my head in the interval time, acceleration is V final minus the V initial divided by, not acceleration, sorry. I want the time, not acceleration. Time is all of that divided by acceleration. So I can put that into Wolfram Alpha. By the way, Wolfram Alpha is my preferred calculator, mainly because it's a unit aware. So I can do this. I can type in final speed minus the initial speed, 0, divided by the acceleration, 1.80 meter per second squared. And as I'm doing that, I'm putting in all the units because it also serves a dual purpose. One, Wolfram Alpha will calculate all the units here for me. And for questions like this, where you might not have been all that interested in this basic SI units anyway, it'll, as it processes the unit, I can see in the final result if I have a unit that I was expecting to get. And I do, great. That means I must have done the algebra right. So 2.78. It's probably right. Let me do the part B. If she then brakes to a stop in 0.5 seconds, what is her acceleration? So I think I'm going to be using the same expression here because I'm still dealing with the same set of information. Really, the only thing that changes is instead of wanting time, I want acceleration knowing time. So now I'm solving for acceleration. Acceleration is, imagining doing this algebra again in my head, then it would be this. So let me try that. Now my final velocity is actually 0. I'm coming to a stop, minus. The initial velocity was my previous final velocity, 5 meter per second, divided by time, 0.5 second. And again, the unit that Wolfram Alpha calculates for me helps me double check, meter per second squared, that is the unit of acceleration. Looks right. Now I get a negative answer, and then matches with the slowing down to a stop. And I think it's meant to be negative. So let me put it in that way. If the question says that's wrong, then yeah. Because, it's one of those things where acceleration is a vector quantity. I guess it's fine that there's enough ambiguity here. Really, I think I'm okay with the positive 10 meter per second squared being graded as correct, but really minus also should have been graded as correct, because this acceleration is in the opposite direction to that, and I think it's not serving students well to say that. So that's there as a reminder for me. I'll reach out to the. It's not one of my questions, so I can't correct it myself. But I'll reach out to the question writer asking if they would make minus the negative version of that also correct answer to be accepted as correct answer. So that's the first question in this set of 5. Let me go through the rest of the questions a little bit more quickly. I've already written down the equations, and they're all going to be constant acceleration kinematics problems. So let me go to the next question, which is previous here. I grouped them, I had a plan. Okay. Assume an intercontinental ballistic missile goes from rest to a suborbital speed of that in that amount of time, and I'm gonna be using Wolfram Alpha and just to put these units as they appear, and it'll do the conversion for me from like kilometers to meters. So it asks what is its average acceleration. So I'm given the speed from 0 meters per second to this final speed and time. So I think I'm gonna be using the same formula. So let me, I guess I shouldn't have erased this so hastily. Let me solve this for acceleration. Acceleration is the velocity at some time minus the initial velocity divided by time, same time. So I have a velocity at 70 seconds, 7.70 kilometer per second minus 0 initial speed, velocity, divided by 70 seconds. I guess it should be like what, 10,000 something. Smaller than I thought. Yeah, I guess that's right. Yeah, 110 meter per second squared. Okay, that's like 10 Gs, 11 Gs. I guess that I think most human beings can't stand 11 Gs for an extended duration of time. Oh, and 11 Gs. Now I wonder if I put it in this way, it might say it's wrong because it'll be off by like 2%. Let me give that a try. Yeah, and so the question did tell me to use 9.8, so I guess it's my fault. Let me divide by 9.8 meter per second squared. It's gonna be slightly more. I guess what, 11.23 maybe. Let's see. 11.2. So 11.2 should be graded as correct. Yeah. So here that wouldn't be errata. I think it's clear enough. Me plugging in G equals 10 is me being lazy, not question misgrading. Next question, third question. So a particle moves in a straight line at a constant velocity of 22 meter per second. Constant velocity. Okay, so 0 acceleration. What is its displacement between? Oh, I see. So now I'm using actually a different equation. So I've been using this velocity equation because questions I were answering, they were asking about the giving me information about speeds and acceleration and asking me for time. Now that I'm being asked about position, I certainly have to use position expression. Let's see. I'm going to simplify it a little bit because it told us constant velocity, which means 0 acceleration. Great. So I'll say acceleration is 0. So the simplified version of that equation is initial position plus initial constant velocity times t plus the rest is 0 because acceleration is 0. So with that, I guess I can just plug in the numbers. Since it's asking for delta x, I can just say, my initial x position is 0. So I just do speed times time, then that gets me 22 times 5. I think I can do that in my head. 110. I think. Let's see. Yeah, it's correct. Good. So that's question number 3. Let's do question number 4. That's the next one, which by next time in previous in this group of question I plan to do. A particle moves in a straight line with an initial velocity of 0. Okay. So this is not going to be quite as relevant, so let me erase that. Constant acceleration of that if t is equals 0 at okay, that still simplifies some of my things. It's asking for particles position at t equals 5 seconds. So let me just write down the simplified version a little bit. I'm still looking for position, the final position at time equals 5 seconds. I can just say initial position is 0 plus an initial velocity 0. That simplifies. Great. This term goes away. So I only have to deal with 1/2 acceleration t squared. So I think I can just plug in the numbers. It's probably too complicated for me to try to do in my head. Although could I? So acceleration is 42 divided by 2. That's 21 times 25. Because 5 squared. 21 times 25. So 25 squared would be 625. And I think if I subtract 25 times 4, which is 100, that should give me the right answer. No, I like practicing my mental math. That's why I did it that way. You can just use calculator. Like mental math is not required. That especially if you are using Wolfram Alpha, that has the added benefit of being able to check the units, make sure you are not making algebra mistake. Like if you forgot to square here, then it would show up in your answer. Not having unit of position. So, but if you don't make algebra mistakes, then great, you get that. That's the correct answer. All right, that's question number 4. Let's do the next question. That's the last in this group of questions that I plan to do. Let me do that. So let me erase some of the marks. So at t equals 10 seconds, a particle is moving from left to right with some speed. At t equals 20 seconds. I see. So it's giving me more information than before. 20 seconds, the particle is moving right to left with a speed of, okay. So sometimes, I think especially for more involved questions like this, I think it's helpful to just doodle a little bit to make sure you didn't miss any information. So it told me at t equals 10 seconds, there was a particle. It's moving to right with some speed. Let's say I'm gonna call this v1. That's t1. And at some later time, at t equals 20 seconds, the question tells me the same particle is not moving from left to right, but moving from right to left with a different speed, v2. Right? So it's asking me for the acceleration. So I stare at this situation, look at the kinematics equations, try to think of which of them will get me to this quickest. And I guess one thing that's good to know is in this question it didn't really tell me about positions. So I think anytime I need to use position, it'll be more challenging. So I'll ignore those, which leaves me with this. Then great, I'll use that. So I guess the most standard way to approach this is to use these snapshots to write down equations. And once you write down enough of equations, you'll be able to see what you can eliminate and so on. So using this snapshot 1, I'm going to write the speed at time 1 was equal to some unknown initial speed plus acceleration times time. And with the snapshot 2, I'm going to be a little bit careful. This leftward, I'm gonna say that means it's minus, like in the leftward, often commonly negative direction. So as I'm writing down a version of this equation, I'm gonna say my velocity is minus v2 at time t equals to time t2 at equals 20 seconds is equal to some unknown initial speed plus acceleration times time. And I should be getting negative acceleration. Let me see if the question will grade that as correct. So so this is a kind of the general physics problem solving approach that I recommend. When you are analyzing a physical situation, first to focus on writing down your equations. This is a way of mathematically expressing the information that were given in the question, given in the situation, or that you can figure out. And once you've done that, then before you do any math, verify that you have enough number of equations. If you have a system of two equations, you should have exactly two unknowns, and vice versa. If you have two unknowns, then you should have exactly two system of two equations. So here I have two equations that I wrote down, and I do have two unknowns: the initial speed and the acceleration. Times I wrote this wrong. This should be t1 known time of 10 seconds. This should be t2 known time of 20 seconds. So two equations, two unknowns. I can solve it. The rest is algebra. So let me go through the algebra. Since the question asks for acceleration, let me start by not solving for acceleration. So whatever quantity it is that you are trying to solve for, you want to solve for the last, because whatever I'm going to solve for right now, I'm going to be eliminating it. So I'm going to solve right now this equation for initial speed. And when I do that, V0 is V1 minus AT1. And I'm going to be using this to eliminate V1 from this equation by substitution. So that's why I was careful to not solve for acceleration, because then I'll be eliminating acceleration. But I'll be coming back to this for part B. So let me first to write down the version with this plugged in. So it's minus V2 is equal to V1 minus AT1 plus AT2. Collect like terms, or they are already collected. Let me factor out acceleration. So it's a V1 plus A, and let me just swap the order so I don't have to start out with a minus sign. So plus T2 minus T1, and then solve for acceleration. I'm gonna skip the rest of the steps and say my acceleration is equal to minus V2 minus V1 divided by T2 minus T1. By the way, this is an answer that many of you might have been able to just guess intuitively, which is great. That means you are experienced in problem solving like this. I don't discourage that necessarily, as long as you also know how to do this systematically. Because that systematic approach, it really matters for when the questions are harder. Yeah, easier questions, many of you can do it intuitively. Great, do it that way. I don't mind. I don't object to that intuitive problem-solving approach, as long as that's not the only thing you know how to do. You should also be able to do things systematically for the harder questions. So 20 second minus 10 second, then that's minus 1.3 meter per second squared, and that's what I contend is the correct answer. I don't know if that's what the question writer programmed in. Oh yeah, that is correct. I guess, yeah, because here plus 1.3 definitely should be incorrect. Yeah. So once you have that answer, then what you can do is you can go back to actually this equation here. Now that you know acceleration, you know everything here except for initial speed. So I'll be plugging in, okay, V1, that was 5.0 meter per second, minus the acceleration, minus 1.3. So those two negative signs will cancel, meter per second squared, times the time at that T1, which was 10 seconds. So that should give me my initial speed, which should be, I guess, a positive thing. 80 meters per second, that's probably right. Let's see. Yeah. So for part C, I guess we are going back to the yeah, so we are looking at a new snapshot. So we are looking at a new hypothetical snapshot number 3 when v of t will be equal to 0. So let me get this same kinematics equation we've been using, and let me write it out. My final speed will be 0. That's equal to my initial speed, which now I know, plus a, which is negative, times, let me call this t3. So t3, just doing the algebra in my head, will be minus v naught over a. And because a is negative, this will become a positive value. So let me plug it into calculator. My minus the initial velocity, 18 meter per second, divided by the acceleration, minus 1.3 meter per second squared. That should give me something in the unit of seconds, 13.8 seconds. Yeah. Again, this is the kind of question that it is more involved than the first 4 questions in this set. But at the same time, some of you who are used to problem solving like this, you might be able to do a lot of this through shortcut, which again is fine as long as you also know how to do it systematically. For the harder ones, this is kind of in between, depending on whether you've seen questions like this before or not. Either you need this systematic approach, or you can take some shortcuts which will help you answer this in 1 or 2 minutes rather than 5 minutes, 10 minutes. So all right, that's the set of 5 questions I want you to do.